Circle theorem. With theorem 1, angle at the center is twice angle at the circumference. So let's put y a equals 2b. This is our shape. So we are going to do a 9 shape here. Yes. So let's divide. Let's join this and this. So you get a diameter here. Yeah, this is our diameter line. So you are divide the shape into 2. So this is a radius because we know that a line from the center to any part of the circumference is a radius. So we have 3 radius here. But this shape, yes, radius, yes, radius. So therefore, this shape is an isosceles triangle. So therefore, 2 angles are equal. So this is our first angle, that's S. And we are saying the sum of the opposite interior angle is equals to the exterior angle. That's why I have 2S. Good. And then the other side, the sum of the 2 opposite interior angle is equal to the exterior angle. So S and Y is our B. Therefore, if you want to find B, it's S plus B. And here is our A. Then 2S plus 2Y is A. So let's factor the 2 out. Therefore, we can see that our A is twice of the B. That's why we are saying that angle at the center is twice angle at the circumference. Let's look at another shape. So this is our next diagram to prove that angle at the center is twice angle at the circumference. Let's do our line. Yes, and the line 2 has divided the shape into 2. So therefore, we have the radius. Then this triangle is considered as what? An isosceles triangles. So therefore, 2 sides are equal. Then 2 angles too will be equal. So you are going to use the sum of the 2 opposite interior angle is equal to the exterior angle. So this is equal to what? The 2s, the sum of it. Then here to y is equal to 2y. That's the sum of the 2 opposite interior angle is equal to the exterior angle. Now, we have here was what? Our B. Then S plus Y is B. Then here 2 is our A. And with our A, we said 2S plus 2Y. So if I take the 2 out, you will see that the A is twice the B. It's very complicated shape, but still. So let's draw a line from the center, to attach here so that we can form a triangle here. Good. So with this is our radius, and we have a triangle here. That's our S. And we are saying that with this triangle, yeah, it's an isosceles triangle. So we are saying that the sum of the 2 opposite interior angle is what? The exterior angle. Good. And here to from here to here 2 is another triangle. And we have Y. So this is our Y. We are still applying that the sum of 2 opposite interior angles is exterior angle. So that make here 2Y. Now, let's continue. So, from here, our B is Y minus S because from this red line to here is Y and this small here is S. So the difference Y minus S is what? B. Then, here's our A. Good. And we are saying that from here is 2Y. So 2Y minus 2S. then we factor the 2 out. So we got A is twice of the B. So with this property, we are saying that the angle at the center is twice the angle at the circumference. With this proof, I hope you understand better. Subscribe to Sneapelus, my YouTube channel, for more videos. Example, under the first theorem, angle at the center is twice the angle at the circumference. In the diagram, PQR, we said that is 65 degrees. Yes. POR. So angle POR is twice of PQR. That's the theorem. Theorem 1. That's what we said. Therefore, POR is twice the angle. So then the angle that is 65 degrees. So you get 130 degrees. So therefore, our S is 360 minus the 130 degrees because angle at the point is 360. So we want to find S. So 360 minus the 130 degree because this here from that's the angle at the point, right? So therefore our S is 230 degrees. That's for the theorem. Circle theorem. So this one is theorem 2. Angle in the same segments at the circumference of a circle are equal. So we are saying that the angle at the same segment of the circumference are equal. So from our diagram here, we are saying that this angle and this angle and this angle are equal. So you are going to prove why A equals B equals C. This is our A, B, and what? C. Right. Let's join a line to form an arc. Yeah, this is a triangle. So from theorem 1, we are saying that the angle at the center is twice the angle at the circumference. Do you remember? So S is twice A. That's from theorem 1. Then the same S is twice B from theorem 1. The angle at the center is twice the angle at the circumference. And theorem S is also twice as C. So if you create them, because all S is equals this, so if you create all the S, you get 2A equals 2B equals 2C. Therefore, A equals B equals C. That's why we are saying that angle in the same segments at the circumference of a circle are equal. Right? Circle theorem. We are saying with our third angle, angle in the semicircle is right angle. That's our third theorem. So we are going to prove why B equals 90. That's the right angle. So this is our B. And this is our semicircle. That's our A. And A is 180 degree because angle on a straight line is equal to 180 degree. Then from theorem 1, we are saying that angle at the center is twice angle at the circumference. Do you remember? So that's from the theorem. So therefore A2 equals 2B. Then let's create the A's. So 180 degree equals 2B. If we divide both sides by 2, our B will be 90 degrees. That's the right angle, right? So angle in the semicircle is right angle. Let's solve some example here. P Q R is 90 degrees because angle in the semicircle is right angle. That's from this theorem. That's what it says. So therefore, in order for us to find the PRQ, (35 plus 90 plus the PRQ equals 180 degrees, right? So if you sum the triangle, it's supposed to equate it to 180 degrees. So we know the 35, do the 90, then you have to find the PQR. Therefore, PQR is 180 minus the 35 degree by the 90. Then our PQR is 55 degrees, right? So subscribe to Sneapolus, my YouTube channel, for more videos. Our next theorem, that's the fourth theorem. Opposite angle of a circle quadrilateral are supplementary. So we are going to prove why A plus B is equals to 180 degrees. And we know that supplementary angles add up to 180 degrees. Do you remember? So this is our A and B. And why are we saying that this A plus B is equal to 180 degrees? So we are going to apply the term 1. Angle at the center is twice angle at the circumference to prove for this. So we are saying that A is twice this. That's why we go to 2A. So if you want to find the angle here, you have to multiply by this A. And then B is also twice the 2B, that angle there. So if I want to find this angle, that's all, is sum up to 360 degrees. So therefore, if I factor the 2 out and divide both sides by the 2, it will be A plus B equals 180 degrees. That's why we are saying that A plus B equals 180 degrees. That's why we are saying that opposite angle of a circle quadrilateral are supplementary. Subscribe to Sneapolus for more videos. With theorem 5, we are still on circle theorems. That's a very interesting topic. Alternate segment theorem. So we have proved that y A equals A. So this is our diagram. Then let's do another diagram. So that's our A, and this two is our A, and it's from the theorem that says that angle at the same segment at the circumference are equal. Do you remember that theorem? Yes. So angle at the same segment at the circumference of a circle are equal. That's why we have A here. And this will be 90 degrees. Okay. So A, this A, this A plus this 90 plus the angle here is equal to 180 degrees. Therefore, we want to find the angle here. Then the angle here will be 90 minus A. Are you okay? Let's move on. Then from this angle to the circumference that touch the tangent here, that's so from this angle is what? From this angle is 90 degrees, and from this angle from here, we said that it's equals to 90 degrees. This angle alone here is 90 degrees minus A. And then know that from this angle, that the tangent here is a 90 degrees. So from this angle here, we are looking for the angle here, right? So therefore, the angle here will be equals to A. If we move this one to equal to, you move this one to cause the equal sign, the 90 will be 0, and therefore the angle here is equal to A. That's why we are saying that alternate segment theorem says that A equals A. So the angle here is the same as this angle. Subscribe to Snapelus. Let's solve one example under this circle theorem. So we have said a lot about the theorems. So this is another example. In the diagram, TB touch the circle at B. That's the TB, touch the circle at B. BD is a diameter. Our BD here, this one is a diameter. Calculate angle ADC, angle ABC, and angle CAD. Solution. Angle AD, that's angle here, B, is the same as angle CBA. So meaning this angle here, 31 degrees, the same angle here. That's what we are saying because we learned from the alternate segment theorem. And we said that the angle here is the same as the angle here. CBA. That's what we said, that this angle is same as the angle here is 30 degrees. Angle BDC. Right, so we are talking about the angle here. Now we know that here, the angle here is 30 degrees, so we are talking about the angle here. BDC is the same as BAC. So the angle here is the same as the angle here. And do you remember this theorem? Yes. What is this theorem? We are saying that angle in the same segment at the circumference of a circle are equal. That's a theorem. That's good. You are following. So angle ADC is what? So which means the angle here and the angle here, that we are asking. Angle ADC is what? Right? This one you have to know because we said that this angle 31 degree is the same as the angle here. So here is 31, right? And then this angle here, the same as the angle here. That's what we said. Angle at the same segment at the circumference are equal. So we are saying that ADC, so both this angle is what? We are saying that the ADC is angle ADB plus angle BDC. So we are talking of this angle. So if we sum up here, our angle ADC is 100 degrees. That's good. Now, angle ACB is what? We are saying that angle ACB is what? And we said that angle ACB is the same as angle ADB. Do you remember? Because we said that angle in the same segments at the circumference are equal. So this angle is the same as this angle here. And we also said that also angle ADB Okay, this angle is 31 degrees. That's what we say here. Angle ADB. That angle here is 31 degrees. That's a alternate segment theorem. So therefore, 2, we are finding A, B, C. So meaning that we want the angle here. And what will be this angle? Right? Now we know this angle. And therefore, we want to find this angle here. Right? And we are saying that this angle is ACB. Right? And we are saying that this ACB is the same as the angle here, ADB, that's the alternate angle. So therefore, this angle here is same as the angle here, right? So ACB is equal to 180 degrees minus the 69, and here too is 31 because the angle here too is 31. Right? So if here is 31, here to be 31. That's our angle in the same segment, the circumference of a circle are equal. So here, if here is 31 too, here will be 31. Therefore, we can find the angle here. That's why we subtracted from 180 degrees. So therefore, our angle ABC is 80 degrees. So this angle here is 80 degrees. Now, let's find angle CAD. Yes. What's the angle CAD? Right? So we want the angle here. Angle CAD. So please give me the answer under the comments. So comment on it and let me see the answer. That's your assignment. Thank you. Subscribe to Senior Pelus for more videos. Bye bye.